Hi everyone, so today I am here to give a knowledge and my topic is Introduction to GraphQL. Before starting the session, let me first remind some basic etiquettes like please join the session 3 to 5 minutes. Please provide us constructive feedback. Please keep your mobile devices in silent mode and feel free to move out of session in case you need to attend an urgent call. And please avoid unwanted chit chat during the sessions. So today our agenda is to discuss about what is actually GraphQL, what are queries, mutations and subscriptions, what is HDL, runtime environment, query languages, what are data fetches, how GraphQL actually works in Java, what is the difference between the GraphQL and REST, the advantages and disadvantages of GraphQL, and then we will have a small demo. So let us start. So GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. GraphQL provides a complete and understandable description of the data in your API. Gives client the power to ask for what they need and nothing more. GraphQL is a query language for APIs, not a tool or a framework for designing APIs. A client gets exactly what it wants from an API, nothing more than that. In GraphQL, we have queries, mutations, and subscriptions. There are three types of operation the client can perform to interact with a GraphQL API. In GraphQL, we can simultaneously run queries, mutation, and subscription so that it increases our efficiency. GraphQL is a collection of three things: SDL, which is known as Schema Definition Language, second is Runtime Environment, and third is Query Language. So let us start with some basic explanation about queries, mutation, and subscription. So queries are used by client to request data from the server. They are read-only operations, meaning they do not modify any data on the server. Queries are used to retrieve data. They specify the fields and nested data structure needed in the response. Multiple queries can be combined into a single request for efficiency. Next is mutation. So mutations are used when client need to modify data on the server. Unlike queries, mutation can cause side effects on the server such as creating, updating or deleting data. Mutations are used to modify or create data on the servers. They include an input object with the data to be modified or created. Like queries, mutation can specify the fields needed in the response. Subscription. So subscription enable real-time communication between the server and the client. Clients can subscribe to specific events and the server will push updates to the clients when those events occur. Subscriptions are used for real-time updates. They define an event to subscribe to the and the data structure to be sent when the event occurs. So queries here, if we talk about queries, then they are nothing but the get call which we use to do in a simple Spring Boot application. So from there we only use them to fetch the data. And mutations are the operations or endpoints which we use to make like the post, put, delete. And subscriptions you can think of an example like if there is any modification being done on the server side, then the particular event will occur and the client who have been enabled for the particular event will get a notifications that this thing has been updated. So the client will be updated every time. He do not have to go and check the documentation again and again whenever there is an update or deletion. Next is schema definition language. Schema definition language is used to define a GraphQL schema. In GraphQL, schema plays a very important role. In GraphQL, schema is used to expose the functionality that are available in an application to its users. For example, we use adding a new book to a virtual library or getting a list of all books from that library or deleting a particular book from a library. The GraphQL schema contains types which are similar to classes in Java. operations which can be performed on those types similar to methods in Java. Below is an example of how do we write the schema in the schema file. In the further slides, I will also show you a proper schema file, but below are just an example of query, mutations, and a simple type which we use to write in a schema file. You can see in the query, we have written two queries like getBook and getBooks. In the mutation, we have written a simple createBook. We can also add here like other things like for updating or deleting. In the third is a type book where we have just like we used to define the model classes, it is the same thing. Next is runtime environment. Runtime environment performs two major operations, passing the GraphQL schema file and creating an in-memory schema from it. Executing the operation is specified in the client request. Passing the GraphQL schema file, reading information from the schema file again and again will be inefficient for the runtime environment. So it creates an in-memory representation of the schema file that contains all the information defined in that schema file. Executing the operation. A user can use any of the operations that were defined in the schema file. Runtime environment is responsible for handling the user request. It looks for the operation specified in the request and then uses the in-memory schema to check if that operation exists in the schema or not. If it exists, then the runtime environment will execute it and will perform the specific action like reading or manipulating the data itself. We'll look into this in more detail in the above side. Now there is a diagram for it. We'll explain you a little more about it. Next is query language. Query language is used by client to use operations that are defined in a GraphQL schema. Query language enables a client to select only the required fields from a set of fields. As you can see in the below diagram, there is a query where we are just firing a query like get book with a book with the ID 1, and we only need details like title, description, ID, and price. And on the right side, you can see that you are getting only the details which you have asked for, like the details of book ID with the 1. We are getting only the title, description, ID, and a price. Data fetchers. Data fetchers is a function associated with a specific field in the GraphQL schema. It's responsible for fetching the data that corresponds to that field when a query is executed. Each field in a GraphQL schema has an associated resolver function. Resolvers are defined for each field in the schema and they determine how the data for that field should be obtained. When a GraphQL query is received by the server, the execution starts by invoking the data fetchers for the root fields. These root data fetchers may in turn invoke other data fetchers for nested fields. Data fetchers can accept arguments provided in the query to customize the data retrieval process. These arguments are specified in the query and used by the data fetchers to fetch relevant data. As you have seen in the previous example, we have provided an argument like book with a book ID with 1. Data fetchers have access to a context object which can store information shared across all resolvers. This context object can contain data such as authentication details or database connection and other details. GraphQL clients often request the same data multiple times. Data fetchers can implement caching strategies to optimize performance by avoiding redundant data fetches. So here is a diagram. As you can see, this is preparing an in-memory schema. So let us see how. First we create a schema file using the schema definition language, and then we create the required data fetchers for the operations required. The data fetchers defined in the schema file then feed the schema file and the data fetchers to the runtime environment, and then it prepare an in-memory schema for it. This overall diagram is a high level of what internally happens. inside the GraphQL. So let us now see how GraphQL actually works inside the Java. Let us first start from the left side. So as you can see that first step is to create a schema file which contain the types and operations that need to be performed. Schema parser class is provided by the GraphQL Java API. We create an object of it to pass the schema file. After passing, we get an instance of definition registry, that is an instance and an in-memory representation of the schema file. Now let's come to the right part of the diagram. Then in the right part we have a data fetches. Each data fetches is associated with operations or field. In order to represent linking between the operations and data fetches, we have to create an instance of type wiring. So there can be more than one linking, so more than one instance of type wiring will be needed. We feed all the data of the type wiring to the runtime wiring. Now we have two instances. One is definition registry and second is runtime wiring. So we combine them both with the help of schema generator class. Then the schema generator class creates an instance of a GraphQL schema. This schema is further used to create an instance of GraphQL, which is the main class of GraphQL Java API which is used to handle the client request. Anyone have any questions here?
Can you explain data fetches one more time?
Okay, so data fetches are mainly we use to define, like suppose if we fire a query, then we use to define the arguments in it. So those arguments are for a particular field. So those things are mainly done by the data fetches.
Got it.
Now let's see some points as for the GraphQL versus REST. So based on a query language, first let's see with the GraphQL. GraphQL allows the clients to request only the data they need, including nested data and latent entities. Suppose if you are a client and you ask, and you are a user, and you ask, you need the information only based on an ID, you need the information only of the name. You do not need other details like the description, price, or other things. So you can fire a query and you will get only the names of the books, neither nothing else. While in REST, we use fixed endpoints that return predefined data structures. Clients have limited control over the shape and size of the data they receive. In the REST, you will need to, if you call for a particular book with a particular ID, you will get it, all the details for it. Neither not a single name, not a single like, you cannot fetch like that. For that, you have to create another endpoint. Data fetching. Provide a single endpoint. In GraphQL, we have a single endpoint for all interactions. Client can specify the structure of the response, avoiding overfetching or underfetching. Overfetching here means like if you need a particular data, like only a single thing, then GraphQL can give you, but in the rest, you cannot do this. In the rest requires multiple. In GraphQL, as we know that we have only single endpoint, but in REST, as we all know that we need to create multiple endpoints for multiple things, like if we need a get request, post request, update, upload, delete, we need to create different endpoints based on our requirement or the requirement given by the clients. Response format. Response format matches the structure of the query and the server doesn't delegate the response format. Clients can request only the data they need, while in REST, response are typically fixed and any change require modification to the server. Different clients may need different versions for the same resources. Next is discoverability. Introspective nature allows client to explore the schema and understand the available types, field, and their relationships. While in the The client needs to require read all the documentation for if he needs the information about the available endpoints or the methods and the data structure. There are multiple other reasons or where differences we can say that in the GraphQL and the REST APIs. So here is a sample GraphQL schema file which we will see in the demo also. Here you can see I have defined 4 things. First is type mutation, where I am just creating a book with an argument type is book and I am passing an input book input and the return type is book. Second is type query. In the type query I have written 2 types of query. On the first one, which is fetching all the books, and its return type is book. As you can see here that it is written inside this block. So this means that it is a collection of data. So it will return in a list form. Second is get book, where we are passing in arguments as the book ID and which is of type int and we return a response in the book form. Next is type book, where we have defined what all things will be inside the book, like its ID, title, description, author, price, and pages. Next is input. The input which we have provided, book input which we have provided here, what will be all needed for it, like title, descriptions, author, price, pages. And this exclamatory mark we have used here, this denotes that this field cannot be remain as null. It is a mandatory field. We can add it on the place where we need to set that this field cannot be null, it need to be present. Any question here? Okay. So there are some advantages and disadvantages of GraphQL. First is it allows clients to request only the data they need, reducing overfetching and underfetching. Second, it provides flexibility and adaptability. Clients have fine-grained control over the data they receive. It has single endpoint, so typically it simplifies the API structure. Real-time data with subscription. GraphQL support real-time updates through subscription, allowing clients to receive real-time data when something changes on the server. Strongly typed schema. GraphQL APIs are defined by a strongly typed schema which provide clarity on the data structure and help catch error during development. And it also reduces the number of requests as we have a single endpoint. So the number of requests will be less as compared to REST. Now there are some also disadvantages. First is security consideration. GraphQL API can be vulnerable to certain types of attacks such as malicious queries or denial of service attacks. Second is caching complexity. In GraphQL, it is a little complex when we go with the caching because it is more challenging as compared to REST because client can request different subsets of data in each query. It is not predefined or we do not define it like this should be the exact structure, so it becomes a little tricky to apply the caching here. Backend complexity. Server can be more complex than REST APIs, especially when dealing with complex queries. Tooling support. If we talk about the tooling support, then nowadays also REST have better tools, library, and framework have been support for RESTful API. Okay, before moving to demo, there are some prerequisites which will be needed, like the basic understanding of Java and Spring Boot. Until now, if anyone have any question, please ask. Okay. Okay, so is my screen visible? Like, can you see the IntelliJ?
Yes,
Yes.
yes, yes.
Okay, so here is a simple Spring Boot application, which is a basically what it is basically doing, it is a book controller. As you can see here, we have three requests, which one is post, get, ends, and another one is get. Here what we are doing creating, adding a data, getting list of all the data, and we are getting a list of data based on a particular ID. So now what will we do? We will convert this simple Spring Boot application into a GraphQL application. So for that, I have added a dependency here. As you can see, Spring Boot starter GraphQL, which will help us to enable GraphQL and its related annotation to use here. Next thing, what we will do, as I have told in the previous slide, that first we need to define any schema, which is plays a very important role in our GraphQL. So let us, as you can see, when you will import this dependency and when you will rerun the Maven, a folder structure named GraphQL will be generated here. Just go on it and create a file name. And remember one thing, like you can give any name before the comma, but after it you need to give GraphQL as. Now let us define some schema here. First I'm defining two queries. First is get books, and the return type will be list of books. Second is get book, pass an argument book, the return type will be book. Next is I'm passing a mutation inside the I will create argument. Input which will be also return type book. Next, we have created this two query and mutation. Now we have to define this book and this book input. So let's define these ID that will be a string description size. Now let us also define oh, like I have told in the previous slide, can anyone just simply guess like what I am missing here in the arguments? We need to pass two things. First is the ID based on which we are fetching, and second thing is the type of it. So it looks fine. Now what we will do, we will go inside our controller and we will remove these and just simply add accurate controller here. Now in GraphQL, what we do, as we all know, in REST we use post mapping for, and we have different methods like post, get, put, and delete mapping. But in GraphQL, if we are doing any mutation operation, then we will use the annotation named as mutation mapping. And if we are doing any query operations, then we need to use annotation as query mapping. So here we will use mutation mapping, and we will define the same name which we have used there. Now it is not a REST call, so it is used here after it arguments, neither not the, and as you know that here we are giving an book and a book input. We need to also take it in this call. Book input. So the one which we have created for the mutation is the method is done. Now let's also do other ones, the query ones. Here we will use annotation name query mapping, and we will define the name which we have used here. So we need to change that here also. One thing which we get by default when we add this dependency is that we do not to define any URL or the path suffix here, which we use to define for REST. By default, it gives us a path of /GraphQLs. We will just, I am using Postman, you can use other also. Just you will give that http :localhost and give your port, and then you can simply /GraphQLs and the API will be accessible. You do not need to define it. You can define, it's your choice, but it is not like if you will not, it will not. You can define it if you need some specification or you need to make it look more good. For now, I'm not doing it. Let us run it. Okay, so it runs successfully. Okay, now let's first do a mutation. I will just do a mutation operation here. Go inside the Postman, you just go inside the body. There is a column named GraphQL. You can use it to write the queries. Now here we will add the things which we have added in the module class or book. Name description and price. And let us take something novel. Description is learning and price is 20. Now let us also, now we need only ID and name. We need to see if it is generating correctly or not. Let us send it. Okay, you can see that our data has been added. Let us go inside the database. You can see that this data has been added now. Let us add one more here. Let me add it by my name. It is added. You can see that it is added here. Let us perform some query operations also. The process is same, you just need to write it here. First, let's see all the records. And we just need to see the names of it, nothing else. You can see that from all the books we are only seeing the names of it, neither the other details which are present here like description, ID, price and anything else. It is this main query. Now if we want to see a particular now suppose if we want to see the third one and only we want to see its price. And we only need the name of it. Now let us see what is the name of the third one is now. You can see that we are getting only the novel one, the third one which is present in here, and we are only able to see its name. We can modify it if we want to see the name and price, and we will only see the name and price of it. Okay, so that's it from my side. Anyone have any questions? If not, Bhati, I think we can conclude here. Hello. Am I audible?
Yes, sir.
Yes,
You are
Swapnil, we
audible.
can hear you.
Yes,
Oh.
yes.
So, Bhati, I think we can conclude here like they do not have any question. Either they
Sure.
did get everything very much, either they do not get anything.
All right, sure, Swapnil. So thank you so very much, Swapnil, for the wonderful session. Thank you, everybody, for attending it.
Thank you everyone for attending this session.
Thank you, sir. Thank you, Bharti.